Well, good morning, or good afternoon, or good evening to everyone, depending on where you are in the world. Delighted to be here today supporting this inaugural DataOps Unleashed event. So, welcome to this session that we've got for you on Going Stellar with OneWeb. So, my name is Justin Mullen. I'm the CEO of DataOps, and I'm joined today by two colleagues and two great speakers. Firstly, David Bath, who's the VP of Platforms at OneWeb, and David's a key stakeholder and sponsor of the OneWeb self-service data hub. And secondly, we've got Guy Adams with us as well, our own CTO here at DataOps.live. And Guy, fortunately himself, has spent the last 20 years in satellite space also, prior to jumping ship into the data world. So we'll be looking forward to hear a bit more from him. We've got a really good session for you today. A couple of things and key takeaways, things that we want you to take away from this session is, hopefully at the end of it, you'll have a good vision of DataOps and DataOps.live and what it is that we do and what it is that we're passionate about. Secondly, an understanding of OneWeb, the challenges it faces, and the vision that they have and David and his team have for a self-service data hub and why they selected Snowflake and DataOps. And finally, we'll hear from Guy in terms of the Snowflake data architecture and how we went around the delivery of the OneWeb vision using Snowflake and DataOps.live. So let me take you into that vision of DataOps.live. Well, it's a simple vision, and that vision is one of automation. And when we talk about automation, we mean automation of everything. So we mean automation of ingestion pipelines, automation of that modeling and the transformation, automation of that whole CI/CD process, the management of environments, the testing, and you'll hear us talk about this so much when we talk about DataOps, but the automated testing at every single stage within the process, and Guy will touch a little bit on this today. But also then the automation of the building of documentation, the automation of grants and masking, and the automation of applying all of those security credentials in a programmatic way, and the automation of audit trail. So that's our vision. And when you think about this, we solved this many years ago, and we solved it in software development many years ago with this concept of DevOps, this concept of Agile, where we enable developers and engineers to work on important projects together and not worry about these time-consuming tasks around deployment. So I guess one of the key questions is, and has been for us, is how can we handle data the same way that we handle software? Well, we stepped back from this a couple of years ago, about 2 years ago, and we started thinking about it, and we were talking with many of our colleagues, Ken Graziano over at Snowflake, Wayne Eckerson of the Eckerson Group, who's also on this DataOps Unleashed event today, also Mike Ferguson over in the UK, myself and Guy, and really we stepped away from technology and started to think about, how do we deliver automation and orchestration? What's the philosophy behind it? What is the right way to deliver data platforms today? And we came up with this philosophy of TrueDataOps. Please feel free to go and have a look at the site TrueDataOps.org. And you'll see lots of content there, lots of information about what we believe. And as I say, it's technology agnostic. And just coming out now, we've taken all of that information and we've taken that into our DataOps for Dummies book, which is due out next month. But you'll see within that, there's a lot of great content, and it's underpinned by 7 pillars that we set out at that period. And they're key pillars, many of which you will recognize from the DevOps world, like automation, automated testing, monitoring, governance, security, but some which are very unique to the data world, specifically how we do CI/CD in the data world, but also things like how we do environment management. So we won't talk through too much of this today, but really just want you to have an idea. So our primary purpose as a company is to say, right, how do we build, test, and deploy data environments in the same way that we do software? And that's what we're going to talk to you a little bit about today. And I think if we think about who needs this and who wants DataOps the most, and many of you will know this, it'll be the biggest customers, and in many cases, Snowflake's biggest customers who we work so closely with the biggest problems and with the biggest visions that they've got, and how they can balance these two typically opposing forces of governance. How do we govern and secure and look after and protect the data that is the most valuable asset? But how do we do that while not reducing the agility of the overall organization? So I'm delighted to introduce you to David Bath from OneWeb and hear more from OneWeb about their vision for a self-service data hub.
Thank you, Justin. Hello, good afternoon, good evening, everyone. It's an absolute pleasure to be here, and I'm really excited to be able to talk about data and data ops from the perspective of a business whose main job is something very different. I lead the platforms group at OneWeb. OneWeb is a global connectivity network powered from space. We deliver enterprise-grade, low-latency connectivity in partnership with local solution providers. These solutions enable communities, governments, businesses, and industries that rely on mobile connectivity, like shipping and aviation, to easily connect to cloud, private networks, and the internet. The fact that we are all joining this remotely is proof to the power of connectivity. Making that reality is a pretty big challenge, though. To keep the latency low, to keep the service feeling like the networks we're all used to in our homes and offices, you need to put the satellites very close to Earth. Ours are at about 1,200 kilometers. The trade-off is that if you do that, you need a lot of time to get continuous coverage, as each one is only visible for a couple of minutes at a time. If any of you receive TV via satellite, you'll know that it's not how traditional satellite systems work. It'd be really annoying if you had to constantly move your satellite dish the whole time to track the satellite. So now that you know you need a lot of satellites, and by the way, OneWeb uses about 650 of them to give truly global 24-hour coverage, the first thing you have to do is to work out how to build them so they're small enough and cheap enough to produce in volume. For this, we borrowed the methods and technologies of the automotive industry, and our factory in Florida looks very much like a vehicle assembly line. It's just quite a bit cleaner. We package up around 36 satellites every month. We put them on a plane and we ship them halfway around the world to a launch site. The second problem to solve is how you put millions of dollars of hardware on top of a giant pile of rocket fuel and set fire to it, and somehow have all of those satellites arrive in the right place, safe and healthy. We stack the satellites on a custom dispenser, which is dropped off by the rocket, and then we precisely release each of the satellites to avoid any collisions. You can see the dispenser here on the left, which has its stack of satellites. All the solar arrays and antennas are folded up ready for launch. That whole unit sits under the payload fairing at the top of the rocket, the bit with the OneWeb logo on it. We take our responsible use of space really seriously. And as a side note, each of the satellites has a special grappling fixture so that it can be physically decommissioned in the unlikely event that we ever lost the ability to command one. So now we've designed a low-cost satellite. We've worked out how to launch tens of them at the same time, dispense them safely from a rocket, and send them on their way to the right orbit so they can be powered on, tested, and start doing their jobs. But if you can only see each satellite for a few minutes from a certain spot on the Earth, how do you get all that wonderful connectivity back down again so you can connect to terrestrial networks like the internet? This tells us about our third problem to solve: building gateways in some of the most inhospitable places on Earth. The challenge is that you need a lot of space so you can build a field of antennas to track multiple satellites simultaneously. And you need to be far away from other wireless systems and buildings, but you also need great connectivity back to network exchanges. And you need to find these locations all over the globe. This is a picture of one of our gateways in Svalbard in Norway, and give you a sense of scale. Under those domes are tracking antennas that are sweeping the sky to pick up each satellite as it appears from one side, and then releasing it when it reaches the opposite side, and tracking back to pick up the next one. The final problem is how the user gets the connectivity. I mentioned earlier that the trade-off for low latency was having to track fast-moving satellites. I compared it to a TV service and said it'd be really inconvenient if you had to keep repositioning your TV antenna the whole time. It would also be really inconvenient if you had to keep moving your broadband antenna. So the user equipment is like a miniature version of these gateways, also tracking the satellite in real time. OneWeb has a few different versions of that user equipment, both with mechanical tracking and electronic tracking, where you don't physically move the antenna, but you electrically combine signals to focus the signal in the right place. So now we have satellites in space, and OneWeb has 110 of them so far. We have gateways and we have user equipment. We must be ready. Okay, I lied. The final problem wasn't how the user gets connectivity. The real problem is how do you bring up this hugely distributed system where every single element is dynamic and no one has ever built one before. Let me paint a picture for you. The first OneWeb launch was only 6 satellites. If you line up those 6 satellites one after another, you get a continuous coverage window from a single point on the ground for about 15 minutes, roughly twice a day. For each satellite, in a roughly 2.5-minute window, you need to calculate where the ground station is, where the satellite is in space, work out where to point the antenna so it's in exactly the right place to catch the signal from the satellite, use the motors to move the dish over 180 degrees, keeping perfect pace with the satellite. And you need to calculate where the user equipment is in relation to the same satellite, point it at exactly the right place in the sky, and track the satellite. And then you need to hand over your data session every 11 seconds while never dropping a packet. Compare this to a cellular phone system. Each satellite is like a cell tower with multiple cells. Even when the user is stationary on Earth, the cell tower is moving. It's like driving down the motorway at 1,000 miles an hour and trying to keep your call up. Once you've imagined all of that, remember you need to do the whole thing 6 times in that 15 minutes, and you need to do it uniquely for every single user. Finally, we get to where data fits into this story. Without access to the data, it's impossible to understand what's going on across all those moving parts. Even understanding each data set is a hugely specialized task, let alone helping others in the company to understand it. A spacecraft payload engineer has a very different specialist knowledge to a resource allocation algorithm developer. Layer on top of this 3 realities that otherwise conspire to stifle collaboration and keep both the knowledge and the data in silos. Firstly, some of the data is regulated and export controlled. The fear of losing control of it leads to both overclassification and an all or nothing approach to data sharing. You can imagine how slow an internal process for approval becomes with that lens. Secondly, the data itself is full of bugs. The nature of a first-of-a-kind system is that data schemas are an aspiration of what a system will record, but your ground truth is something that improves quite rapidly with system maturity. And lastly, when the task to relate different data sets together is Herculean and very manual, important derived data are created and recreated by each team or analyst, and there's no time to do any real work. So to be successful, we started with this vision for a new data-driven operating model, a vision of self-service, democratized data, where data owners are in control of their data and are sure they know who's using it, where data can be explored and consumed safely across the boundaries of geography or department and supplier, but one where the price of admittance to this open data club is that you steward your data, you describe it, you publish it for everyone, and you commit to contributing back your derived data sets so we don't keep solving the same problems over and over again. In short, strong governance, but without stifling autonomy. DataOps.live and Snowflake have got us from vision to production in a frankly terrifyingly short time. Most importantly, they've done that while the organization, the system, and the data is constantly changing. Creating clarity and repeatability in this hugely dynamic context is their unique advantage. And Guy is now going to help us understand some of the key technologies that made it possible to build.
Thank you, David. So picking up on some of the points that David mentioned, one of the things it's important to understand about a satellite network is just how complicated even simple use cases are. Doing troubleshooting on a single satellite connection, for example, requires looking at the ground network, the Earth stations that David talked about, requires looking at the satellite, requires looking at the user terminal that's on the ship or the aircraft or the remote location. There's obviously then all the conventional things like the terrestrial network to worry about. And all of these different elements generate data, potentially significant amounts of data. The very first data set that we worked on this project was generating over 0.5 terabyte a day. And when the fleet gets to the 650 satellites that David talked about, this is going to be tens of terabytes per day. And that's just one piece of equipment in one of these locations. The other challenge with this data is that it's incredibly diverse. It obviously comes from different places, it comes from different vendors, it comes in different protocols, but it's also differently available. Some of the data from the satellite is only available periodically when it passes over certain locations. So you can't guarantee having all of the data exactly when you want it. And that creates some real challenges when you're trying to join data together, because you may only have at a point in time a piece of the picture. So how did we go about this? Rather than taking what may have been a traditional or obvious approach of putting all this into a single Snowflake instance, we actually took a slightly different approach here. And we took each of these departments, each of these areas of data, and we created a separate Snowflake tenant for them. David alluded to some of the requirements, in the self-service data hub for very strong autonomy and independence for each department, but without giving up on the governance and security. And the model that we used here really provided that. So each department brings in its own data, but they're also then able to share all or a subset of that data with other departments through Snowflake secure data sharing and the private data exchange. So OneWeb have a private data exchange that allows each of these departments to share sets of their data with the others. So for example, the ground network, when they're working on an issue, can cross-correlate their data with the data from the satellite group or the user terminal group or the terrestrial network group. There are also some departments who don't even collect their own data. They collect data from other departments, they enrich it, they add value to it, maybe they understand the overall big picture better than other departments, and they're even able to produce derived products and derived outputs of that data, and then they can share that back into the private data exchange to be available to other parts of the organization. So the key benefits of this approach were separate tenants give very strong governance, give very strong geo restrictions, which David alluded to. Some of this data is very geographically sensitive, and make access control over this data very straightforward but very powerful. But it also gives each department full autonomy. It means each department can innovate at their own speed, can add data, transform data. Essentially, they are their own local sysadmins, but without giving up any of the governance and the ability to share data between organizations that's so critical. And this whole approach, the Snowflake plus DataOps approach, which we use, allowed us to get to time to value incredibly quickly. And David talked about this a little bit, but we got the pilot mobilized up and running in the first week. Within 2 weeks, we were showing real use cases, including bringing in, 0.5 terabyte plus of data a day. And this was actually used in production within 4 weeks. Whilst we were doing this piece of work, the initial pilot, there was a requirement came from another part of the business asking if people could generate and export some files to work with, to provide to a particular partner who they're working with on deploying this network. And someone realized that actually generating and trying to FTP or copy around a set of files is really not the way to go in the Snowflake era. So they asked us if we could add that tenant and add data sharing to that tenant into the pilot, and that happened within a few days. And within a few minutes of turning it on, that partner was able to access terabytes and terabytes of accumulated data in seconds, because that being the power of data sharing. So that's kind of how we put together the Snowflake infrastructure to support this. Let's look at the DataOps piece of this. So we built this project from the ground up using the very strong TrueDataOps principles that Justin talked about at the beginning. So we built everything from the ground up using our DataOps platform. We put everything into a single source of truth. And from that, we were able to build these pipelines, these DataOps pipelines, to deploy to the production system. But one of the things, if you think about getting a pilot mobilized within a week and having production use cases within 4 weeks, you're having to make lots and lots of changes very, very quickly. And a key part of that is the ability to manage change, to test change, to allow to have multiple teams and multiple parts of a team doing independent pieces of work in parallel. So the environment management aspects of DataOps was absolutely critical to achieve that success and that quickly. So in addition to the DataOps platform being able to deploy to production, we also run a QA environment, we also run a development environment, and every time one of the engineers wants to do a piece of work, they're able to spin up a dynamic environment, we call a feature branch environment, do their work, test their work, and then merge that back through dev, QA to production, and they can do a complete turnaround of this, typically in around an hour. So they can take a feature, or a simple feature request, generate a feature branch, do all of their work, test all of the work, create all of their automated tests, go merge request into dev, merge request into QA, and finally get back into production. And they can do that in an hour. And that's what allowed this incredibly fast time to value that David talked about. It's worth looking a little bit about what these deploy pipelines look like. So there's a lot that, and obviously these are very specific to every organization. This is an example of what one would look like in the satellite space. The steps in the pipeline will obviously differ from organization to organization, but they generally have a set of commonality. One thing that pervades every pipeline is the environment management. These pipelines have to be environment aware. They have to understand the target environments. Are they writing to production? Are they writing to a feature branch? And they behave differently. So for example, in feature branch environments, we use zero copy clone. One thing that was really important, as we've talked about a lot, there's just a huge amount of data coming in. So all of the ingestion steps and the very, very high volume ingestion steps were a key part of these pipelines. We strongly advocate automated testing throughout pipelines, but in particular, testing after an ingestion stage. There's no point in going and transforming data and modeling data and publishing data if the data that you started with, the data you've just loaded, has problems. So we've created post-ingestion testing steps. That mean we ingest new data, we then test that data to make sure it's valid before we proceed to the next steps. The next steps are usually transformation steps. So this is where those departments are actually either enriching their own data, adding value to their own data for other departments to understand, or they're starting to join their data with other people's data to produce that end-to-end picture, for example, that we know, that we saw in the first slide. You can't get an end-to-end picture looking at any one system. You have to be joining 2, 3, potentially 4 data sets together to get that overall piece of the puzzle. Then we do some testing at the end because we've derived some new data, we've applied some new logic to it, and we want to make sure that the results of that are good before we share it. And then finally, we publish that out to the private data exchange so other departments can see it. And we can be running this pipeline every hour, we can be running this pipeline every 15 minutes, potentially even every 5 minutes. So we can be pushing new data through and making new data available to the rest of the organization very, very quickly. Now that's looking at this in the context of one tenant, but if we go back to that original picture, remember there are multiple completely independent Snowflake tenants as part of this organization, all interacting through the private data exchange, which means that we've actually got multiple DataOps projects rolled out, one for each of these departments. And so each of these departments will have their own projects, will have their own pipelines. They're all coordinating, they're all under a single OneWeb umbrella, but they are all independent of each other. And again, this goes back to, it allows those departments to innovate, iterate very, very rapidly without having to worry about getting permission from someone else or coordinating with someone else. And once they're finally happy with it, then they can share the results of that with other departments. So hopefully that's given you a little bit of idea about how we use the power of Snowflake and the power of DataOps to bring what's a pretty incredibly complicated problem and not just achieve great results in it, but achieve great results very, very quickly. And we're looking forward to a long partnership with OneWeb as we take this and solve many, many of the challenges of deploying a low Earth orbit satellite constellation. Finally, we'd like to invite you to take the next step. Come and visit us on our virtual stand at this event. Where Justin and myself are both available for the rest of today. If you're interested in lifecycle management of Snowflake, we've got a new series of blog posts that's just gone up on our website about them. Certainly would encourage people to go to TrueDataOps.org and have a look at the material that's there. That is technology independent. That's a philosophical view of DataOps and how to implement it. And finally, if you're a Snowflake customer, you want to become a Snowflake customer, or you want to try out DataOps, go to Partner Connect in your Snowflake tenant and one-click sign up. Finally, if you have any other questions, please do email either Justin or myself directly. Thank you very much.
Well, thanks, Guy. That was brilliant. And thanks everyone for joining this session today. Hopefully that gave you a real feel for one of Snowflake's biggest customers with some enormous real world challenges and an amazing vision for a self-service data hub and a culture of self-service analytics. And how DataOps.live and Snowflake have gotten OneWeb, in their own words, from a vision to production in a frankly terrifyingly short time. And most importantly, helping them do that while the organization, the systems, and the data is constantly changing. A great testimony from a great client. Thanks, David, for the session today. And so to finish up with, we'd like to leave you with a few short things. First of all, a short 90-second video just on DataOps for Snowflake, an overview of it, and the value that DataOps and Snowflake can bring to your organization today. And for any of you that have got a further challenge of dealing with IoT time series data in this world of DataOps. We've got some particularly interesting technology in this space, and we follow that with a short 90-second video on our Gallium technology, which is around the compression of IoT and time series data. Enjoy.
Every day, business teams want to ask more from their data, but that means more changes to their data pipelines and their data platform. Why can't data teams make changes in minutes and hours like our DevOps teams instead of days and months? Data platforms are complicated. Data platforms have tools from many vendors. Data platforms are looked after very carefully and require lots of manual intervention and protection. So data teams are overrun with demand and business stakeholders have to wait for their changes. What if we could bring the speed and agility of DevOps and CI/CD to data platforms? With the DataOps for Snowflake platform, you can move your source of truth to Git and treat your data platform like your web platform. Build and rebuild your data platform from Git repository in minutes. Clone complete data environments in seconds. Create feature branches of the code and the data platform for every new feature a stakeholder requires. Develop new features faster and in parallel. Reduce errors with automated testing. Increase productivity. Track every change ever made. And reduce your total cost of ownership dramatically. Go to Amazon Marketplace or Snowflake Partner Connect today to switch on DataOps and see for yourself. Every day, we use technologies that dramatically reduce the size of data. What we see is a tiny % of the original information, but to the human eye, it's virtually the same, and we base our decisions on this. Gallium does something similar for time series data. So how does it work? Imagine if we wanted to pick the 1% of most valuable data from this picture. Which 1% would we send? It's clear that some points of data are much more important for the overall picture and our ability to answer questions about it than others. Gallium does the same for time series data. The traditional way for reducing time series data is averaging or downsampling. Gallium takes a truly unique approach. It determines which points in the data carry the most valuable information for answering questions and decision-making. In fact, Gallium tags every data point to say what level of accuracy that data point contributes to, and you can use this Gallium tag to specify the accuracy required on any question you ask the data. Gallium is a pure software solution, so it can run with any sensor device or on databases and data warehouses. Contact DataOps to test Gallium using your own data and see for yourself.
Thanks, everyone. That's the end of our session. And it just leaves me to say on this very special day from a true Irishman, happy St. Patrick's Day to you all.